Yeah. Uh-huh.
I connect to my laptop here.
Yeah, you can connect it with VGI. We have HDMI and this.
Does it work?
Yeah.
Looks good.
So you have a clicker, right?
Oh,
Excuse me, what presentation do you have?
The over. I have time, not now.
Yeah, okay.
Just
So,
checking
yeah.
if I have everything I need here.
musíme takto. Musíme ho najít, no.
This is the right one.
Yeah, this is the right one. Yeah.
Tady překliknout počítač jedna.
Oh, jo.
Ten nejvyšší.
No, lepší, no. Tak jo, počítač. Excuse me? Excuse me? Going to the Kubernetes talk today?
No, the Kubernetes is elsewhere because the schedule changed. Sorry, I will. I'm this application.
Řekněte, že je to špatně, ty systém to ještě neřekli.
Kubernetes are going to be in one file substance.
Ale teď už to propojený nebude, jestli se díval
Teď už to nebude, no.
Let's give it another try. Does that work? Yeah. Works good. Another try, yeah. Good morning. Haha. We have another minute, so don't worry.
Microphone if there will be any questions. So
I think it'll be
Can I ask a question, please? Is this the presentation about Kubernetes or is it Architecting Mouse Enterprise? Because the paper said
The schedule changed.
the schedules change, and what is here, it's up in a D105. Oh, no, the real program is next to the door.
sorry. Thank you.
Good morning, everybody. It's kind of a rough start. 10 minutes for changing rooms, isn't that nice? But yeah, obviously most of you made it. Welcome, my name is Markus. I'm obviously working for Red Hat, so I have a cool job title, which is developer advocate. So I should run around and talk about all the fancy stuff that we're doing in the middleware area, so all JBoss basically. And I've been working as a consultant like many years. I think all in all, it's been 14 before I joined Red Hat. And there was a lot to learn over that 14 years when it came to enterprise projects. And this is basically kind of a little recap, what we learned in the past, how architectures evolved over time, and a nice little outlook. I think it's not going to duplicate a lot of what Mark Little already said, but he threw out a bunch of buzzwords, and I'm trying to put that a little bit more into context for you today, and let's see if we can make something nice out of it. This is one of my favorite quotes ever, like in No Change. So we've always done it, and the question is what we're doing today, is it only popular? Is it the right thing to do? And if you look back and try to recap how Java EE applications actually looked like for a very, very long time, it's exactly that, right? So let me just quickly see who is actually working in Java EE on projects, like customer projects. Okay, fair enough. Most of you. Who's seen that kind of architecture? Who's using it? I mean, a bunch of enterprise application EF files deployed all over the cluster, thank you. So we have WARs, we have our EGB jars, it's all packaged in one container. That's pretty much what we've done, right? We have some enterprise access management systems or other cross-cutting concerns. That's the legacy, right? So if we hit a 3-letter customer today, this is pretty much what we find. The technical implications are easy and straightforward, and we've all seen them, right? That's what we call monolithic in the classical sense. When we try to reuse code at any level, if it's a module or if it's a more business-driven feature, we might end up using jar files to put them into different deployment units. My favorite here is that we had that big push to production twice a year. So we've been working all the waterfall down, and twice a year, probably at the beginning and at the end, right to Christmas, we definitely pushed something out. We did push stuff on Christmas, believe me. What else? Single database scheme, okay. It tends to be, it feels heavyweight, right? So the whole infrastructure, just think about that blue products, right? So I'm naming WebSphere here, just who has ever had the pleasure to install WebSphere? Oh, fair enough, right? So it just takes hours, and depending on the system you're working on. It's kind of setting up a development environment is a task for a bigger project that could easily take 2 or 3 days. And that's definitely not a matter of documentation. It's just bloated everywhere, right? Some more stories from my past. I used to work for a department which gets called when everything already hit the wall or was driving at 200 kilometers per hour and basically just 2 meters in front of the wall. So whenever I came into a new project, I basically had to learn what's going up here and what's going on. So the first thing for me was trying to understand what those guys have been writing over the past years. And I looked at the test cases, and it's pretty cool because thousands of test cases actually are there, but no new ones, mostly no new ones. So only the start of the project was really, really sufficiently covered by test cases. Whenever new features came up in the past, they barely have been tested at all. And it's been large projects, right? So, and not only from a code perspective, but also from a team perspective. So bigger than 20 team members, no issue. What else? We've seen that. Most interestingly, I've always seen a very technical approach to those designs, right? So we've not looked into microservices back in the days. We've looked into layers and technical layers. So we've been doing kind of persistence layer, a business layer that hasn't been cut that well, and we had that fancy presentation layer. Yeah, we heard about some architectural approaches, but that's not really what we've been doing back in the past. Domains or business components, like in services or what SOA requires, not really there. What else do we have? Yeah, funny enough, even if the teams are pretty big, you really need to have a good overview about the whole project. I could quote, I mean, this thing is recorded, so I can't tell you that much from my past and don't mention names at all, but imagine that we've had a nice little project which was kind of a BI project, and it was built on Eclipse. And this thing had real technical design in it. So whenever a new function request, a new business requirement came in, we basically had to duplicate all the reporting stacks because it's been technically just putting them next to each other. And the application exploded, and it was completely impossible to fix errors because so many code lines actually have been duplicated. And it's really hard to put some cross-cutting concerns in there. If you actually know the customer behind that story, yeah, anyway, we're still alive, aren't we? And even if we managed all that, it's exactly the fact that the still changing requirements don't really have the power to change the design of those architectures. I've no idea why, but whatever new features came up, they tend to be huge. All the estimations run into a couple of 100 days. And that's all because those legacy applications have been grown over years, and nobody really looked after suitable designs or implementing features the right way. Most of the stuff just needed to go in there. But why? What's the reason? I mean, a bunch, right? So technical debt. It's all moving faster than we can adopt the stuff. It's just grown. We can't change it. All the experienced team members have been pulled out, right? So, I mean, who's not seen that before? 20 people in a project, and after 1.5 years, all the experienced people get pulled out. It's not open source, mostly. Project work just works differently, right? And of course, we've been lazy. If we had an easy way to implement something, we've been doing it. And nobody cared for educating himself, right? We've just been working, pretty much it. And if we've been home at night, we didn't really want to educate ourselves anymore. And many, many, many other excuses, right? So I'm not sure if those were the right ones, but it was obviously not the right way to go for application architecture, at least not at that size and scale. So what did we try from there? The idea was pretty easy. Let's just slice those big monolithic applications into pieces. And instead of wiring jar files and stuff like that, we use services. And we try to solve integration problems from there. Web service, all the things, put an ESB in the middle, and just make it a little bit more complex by having a little bit more applications, and just let everybody talk to everything. And we do some little routing in between, right? So the ESB is the perfect place to shift business logic from left to right. The customer isn't exactly the same customer in two systems. Thank God we have an ESB in between. We can put some logic there. Great, fancy idea. Did that change anything? I mean, we have still very large code bases. Nobody wanted to touch that. And the bloated IDEs, who has ever worked with an ESB or business rules workflow stuff? And I'm mainly speaking of the big vendors, not the framework-oriented approaches that we use. It's just incredibly large. I know some IDEs have a download footprint of more than 3 gigabytes. IDE, kidding me? Okay, it's incredibly hard to understand. Nobody really knows what's going on in those infrastructures. And it's surprisingly difficult to scale. ESBs are a beast of its own. So having a real good scaling strategy for that was very, very hard. Yeah, and mostly nobody really rewrote something. People tend to put new features into the ESB layer, right? So instead of changing the applications and the interfaces, fixes got introduced in the ESB because we had a chance to. So don't be surprised if you open workflows in one of those heavyweight ESBs and you end up with millions of lines of code of transformation, message routing, or whatever. It's not very, very brave and nice, right? So basically I'm saying that we haven't found a nice way of designing large enterprise projects. Did I? Who knows what that is? It's basically a system infrastructure of a corporation you would love to see here. It's Netflix. So this is actually a design of the system infrastructure of Netflix. Seriously, that looks scary. But I can tell you one thing. We in Germany, we already have Netflix, and it works. And not like most of the time, but always. I might have been locked out once, but that's pretty much it. Oh, sorry. What did they do? The issue is they actually decomposed what they had. They decomposed their monolithic applications and evolved them into something that Mark just talked about a couple of minutes ago, microservices. And I actually don't like the Martin Fowler approach. This looks a little bit cleaner. What do we need to do? We need to basically find a way to encapsulate the root of all source changes and make them independent of each other. This is kind of best of breed, isn't it? Whenever you hear something about design and software architectures today, you basically end up with triple D, domain-driven designs. You hear something about bounded contexts. You need to design everything for automation. Stuff like that. This is a talk on its own. And I'm definitely leaving you with that page here for your homework. So if you really want to think about microservices, one of the first lessons that you need to do is look into all those design constructs and ideas and methodologies. Because what we do, and that's the real difference between microservices and ESB approaches, we really want smart endpoints and dump pipes. So instead of putting every logic and transforming and routing information into ESB-like infrastructures, we want really, really dumb pipes to wire the services together. And how to find them is probably the biggest challenge. This is something that has been haunting me for years, especially in those big and large projects. Whenever it came to implementing a new feature and finding a way of doing a new service in something that exists since ages, it's incredibly hard. And I found this gem. If I put down the URL, and most interestingly, it's back from 2008. So this is also something that is out there since ages. Depending on what you really want to do with your service, you could basically decide about the size. Another talk of its own. So you get a lot of pointers today for more research. Because of all my background, Java EE is what really moves me. You could do microservices in whatever language or technology you'd like to. But I'm still kind of a Java EE guy. And I've never really wanted to change that. So the question is, how to teach microservices to Java EE. This is what we had, right? So our ear. This is before somebody came around the corner and told us about microservices. How to move this application. What about that? This is actually an approach I've been doing for a couple of years already. So whenever I had a chance to put my fingers on a component that needs to be fixed or changed or evolved or whatever, I try to extract it and make it a component on their own. And this component basically is what I'd like to call a service here. So the first thing you really need to do is pull that changing item out of your application. You might need some glue code in between. Everybody talks about protocols, and we might, how do services talk to each other, right? So HTTP might not be the most performant way of doing things. We might end up having to send messages in between. So we need some glue to put our new service into the old world and make them work together. But at the end of the day, this is a feasible way. What else do we need for services? We need lightweight bootstrapping, right? So everybody who's talking about microservices in Java these days actually has that one-liner. So Java, jar, execute, start, main, whatever. So this is the ideal microservice. This is not exactly what Java EE delivers. Java EE still, even the fastest servers, are a little bit more feature-rich. We have something in there for everybody, and we can do far more than just execute a single REST-based web service, microservice, whatever you name it. So how could a microservice actually look like in Java EE? That's it. Surprised? Looks pretty straightforward if you ask me. It's just an EJB, and it's exposing a REST JAX-RS endpoint, right? So how could we deploy all that? In a WAR file, right? Since E6, we actually have the chance to use EJBs in WAR files. So there's no need anymore for extensive packaging. So no EAR files. We could actually end up using a tiny little piece of the whole Java EE spec. In this case, we might be good with JAX-RS, some EJBs, a little bit of cache, a little bit of persistence. That's pretty much it. Is that all? Seriously, that's all? Okay, I'm lying. This is missing, and this is just a loose collection of buzzwords as of today. This is everything that came to my mind while writing that talk. So we're still missing a lightweight runtime, even if Webfly can spin up in seconds and it's blazing fast. We could improve that a little bit. Cross-service security is something that's not really covered by Java EE. What else? Transaction management between services, JAX-RS and transactions. Load balancing, not really defined. Service discovery, it's all not part of Java EE, right? So what could help? What could help us to make Java EE a little bit more better? And what does a real Java EE microservice, which really looks appealing to me because it's just that tiny little class. This is what we need, right? A complete stack. We need a little bit of the hardware stuff that nobody from the middleware group actually looks into. Or we need a hypervisor, we need a bunch of VMs, and our service. That's a hell lot, isn't it? If you imagine, I mean, look back a few slides, the Netflix picture, did those guys really spin up a complete virtualized environment for all their services? Probably not, at least not that way. What else? I think Docker will help a lot. At least we have a really, really nice way to define how individual instances are configured, and we could preload them. and scale out pretty easy. Still, even if we use Docker, we could cross some red points from that list. There's still a lot that's left, right? So we're not there yet. No discovery, more points, service versioning, governance, failure handling, circuit breaker. What about cross-service logging? Who wants to really look into 20 million log files and trace a user request? Nobody. My pitch is, let's not try to solve everything at once with Java EE, okay? We just need to evolve our designs, which might be the suitable approach in general for enterprise E projects, because evolving design is something that is mostly missing so far, and that's something that is badly needed in 15 to 20-year-old projects. So let's just one step at a time. If you get a chance to evolve something like a Java EE application into the microservices age, this is what you need at a minimum. You need some kind of the basic left side, so the load balancing infrastructure. I assume it might be boxes. It might be what you already have, like HTTPD service and some nice fancy proxy plugins. You might need an API gateway, because versioning of services is something that you really don't want to implement. You want some external thing that does it for you and which you can control in a good sense without having to deploy something new on your service. You need some service registry if you're starting to scale out. And scaling out definitely is something that goes beyond 20 services, but it starts to be messy if you're using 20 plus services. So you need something like a service registry. But that's it. The most simplistic example. And the next question I typically get is, how does that look like today? And what would you recommend to use? And this is what I try to put together here, because we have a bunch of products and projects that we actually could use here. Fabric 8 is pretty cool when it comes to service discovery. And Fabric 8 is, yeah, as I said, the orchestration layer on top of Docker. You call it whatever it is. Mark, is there a 20-second pitch for Fabric 8?
No, it's a 20-minute.
It's a 20-minute pitch, so let's not look into it. They're moving into the Docker direction and Kubernetes, so it's a pretty solid vision of how middleware microservices could work together, all kinds of microservices actually. Undertow is the web server in Wildfly. It has some pretty cool load balancing features as of the latest version, so whenever you grab the latest bits, which is actually Wildfly 9 as of today, you can really use that as a load balancer, and it's lightning fast. API Man is a pretty new effort. It's a little bit more than just an API management. It also provides some security features. So this is something that could get you started. You could run it on Java EE instances, most notably Wildfly, but also standalone somewhere in your infrastructure, so that works good. And of course, our services need to run on a lightning fast application server. Use whatever database you'd like to. If that is the basic setting, all I could tell you is from here it's getting more complex and a little bit more distributed. And this is probably one thing that still is a little bit underestimated, because the more complex it gets, the more distributed it gets, the heavier it is to administrate and develop. And it's pretty good to see that we finally start to see a first bunch of design patterns around microservices. And if it's really SOA done right, because this time it's not the business guys defining services, it's more the hackers doing services the right way, then we definitely need to do our homework here. This is the first multiple service design approach, if you like to call it. I haven't given it a name so far. You basically have a load balancer in front of all your individual services, and they get called by the client. In this scenario, the client basically knows about the 3 services. Does that look familiar? This is something that we've been doing for quite a while, actually when it comes to mobile development. This is what we do when we have our Facebook apps today, or let's not make a good example. The client knows about all the API endpoints on the server and does all the navigation logic itself. On the back end, it still could be microservices. What else do we have? We can chain that a little bit. If we want to hide the individual services a little bit better, then we definitely can call services from services and chain them together. This might be suitable if you need to use different protocols between services. So you really want to have one REST endpoint towards the client and use some other service protocols in between the other services. It's mostly going to be a lengthy call, so because we don't have any asynchronity here. But speaking of that, we end up having our next scenario, which is this. So we start to use microservices design and have kind of a dependency graph. So the services start to spread out a little bit. We can use asynchronous and simultaneous processing in here. And actually the services definitely could use same resources. What else do we have? 1 dB for 2 services. If that is a good idea, I'm not sure yet, but it definitely makes sense. Speaking of big ERP systems, you end up having a domain object, which is the one I like the most is actually the customer, because a customer tends to have different attributes of the whole life cycle from left to right. So if you have a service that takes care about your customer, it definitely needs to know a lot about it. So it might make sense to evolve those customer data and edit over the lifetime of your relationship with the customer, or just use a different subject for it over the lifetime of the application. So depending on the real needs, if you're able to define that single customer for the whole organization, you might have some services that just use the same database. And the 5th approach is something that I personally believe will be much more suitable for enterprise applications. In this case, we have some queues in between. This is also looking pretty similar to some IoT architectures lately. So whenever you think about home automation, stuff like that, you have all your individual devices talking to each other, and MQTT is one of those device-to-device protocols. It might also be suitable actually to use some queuing and asynchronity in those microservices architectures. So it's definitely not our REST and HTTP what we're doing between services. If I wouldn't know that RMI and all those stuff is probably going to drop from Java EE sooner or later, I'd actually also recommend doing that, but it's just about how many services you call from other services and how big the fan-out approach actually is. So the more services you chain together, the longer the individual requests actually take. But at the end of the day, it's easy as that. So please don't forget, complex runtime, many moving parts, multiple instances. Just take a look back on the slide with the Netflix architecture. We still haven't solved all of the problems. we haven't talked about failure handling in that services. There's a whole slide of question marks, which Java EE definitely doesn't solve as of today, for which you have to look into something. One part of the story is definitely DevOps. So a lot of the question marks from the slide before can be solved by an automated process and by DevOps. So if you want to do that right, do DevOps. I'm not saying that enterprises are ready for it today, but we might need to get there to do microservices, right? But still, this is only the beginning because there's so much more out there. Circuit breaker, failure handling, there's something called Hystrix. Netflix is actually spitting out more libraries and frameworks at the very moment than they have problems. But still, it's all pretty new, pretty bleeding edge, pretty fresh. So before you implement something on your own, make sure to look around at least at those projects which are probably pretty much what you need as of today. My takeaway for today, if you think about microservices, decomposition and design is still the absolute must. Before you start doing anything, start thinking. And it still needs to balance between real requirements from the business and the cost that it generates when you implement your final solution, right? So, question of the day, are they here to stay? Just give me your hands. Are we going to do microservices from now until the future? Oh, nobody believes that. Okay, fair enough. I can tell you, definitely not. So what I'm pretty sure of is that monoliths should be dead, and I think they are pretty dead because I've seen so many failing, and I've seen so many who are barely able to move a bit since 5 years anymore. So we need to find a more lightweight approach to serve a lot more requests and to have a better application design, even for Java EE applications. Thank you. Not right in time, but almost. Do I have a question left? So if anybody wants to fire a question, otherwise I'm here. I have another talk tonight at 7 p.m., which is going to be a little bit more about Java EE and community, how to participate and how Java EE is governed. So if you want to join me, it's going to be like a BOF, I guess. Thank you.
Thank you for finishing it rough today.
Yeah.
Cože?
Give me a second.
Jo,
Just need to unplug it.
A vydáváme do toho.
já si myslím, jak jsme ten další bodec.
40, ne?
Γιατί όλοι οι developers εδώ.
Můžu tam lifruje.
Sorry. Or here is HDMI or the VGA.
What okay, so I can use this one, I guess.
Okay.
That's like only wireless. No, only wireless.
Only wireless?
Only wireless.
Okay. Yeah, okay, I'm going to mail Wi-Fi
Ne, žádný jsme tady dostali. Nemají?
Okay, so there was an issue